Hello everyone. So today we are going to start with the module 2, that is process management. So in the module 1 we saw the basic of process management in the operating system. So now the module 2 is completely about process management. So before going in depth of the process management, first we'll try to understand what is process. Okay. So we already know. So process nothing but the program. Okay. Whenever we have a program under execution. Okay. So whatever the program it can be. So whenever it is under execution, we call them as a process. Okay. And okay, so now this is the basic of process. Okay, so now we'll see how this process memory, okay, in the memory concept, how this process memory is divided. Okay, so process in a memory, how this process will work with the memory concept. Okay, so it will have a four division parts. Okay, so the first part is stack. Okay, so this is the zeroth part and this is the maximum of our memory. Okay, it can be a maximum memory. So this is how the process in memory. Okay, so here we have a stack part. Okay, so that grows in this direction. Okay, again we have a heap part here. Okay, so that goes in the opposite direction. Okay, then we have a data part here and we have a text part here. Okay, so we'll see what are these four divisions in the memory. Okay, so first part is, so whenever we say process memory, okay, for a process the memory will have a four divisions. Okay, so first is stack. Okay, so what the stack is used now, so for the temporary data. Okay, we'll have some temporary data whenever we're running a process. We'll have some temporary data. For example, local variables, will create local variables in the program like int c. Okay, so like this local variables, and we'll have a function parameters. Okay, again we'll have a function return values. So all these are the examples of temporary variables. So all these temporary variables are stored into the stack part. Okay, so next comes the heap part. Okay, so the heap will, it's a memory that going to be dynamically allocated. Okay, whenever we want to allocate some dynamically memory. Okay, whenever we want to allocate dynamic memory, so that time, okay, so dynamical memory allocation is done. So whenever the process is running, okay, the process is running in the runtime, we want some memory to be allocated. So in that case we'll use the heap part. Okay, so next comes data. So in the data part we'll have some variables like global variables in the program. So all these ones is stored into the data part. Okay, and the last one, that is the text. Okay, text is nothing but the, it is the real program. Okay, whatever the program we write, okay, that program code. Okay, you can say it's a compiled program code. So the compiled program code is stored into the text part. Okay, so in the middle you can see this is the free space. Okay, the stack is allocated from the top and it grows into the opposite direction. Okay, and the heap is goes into the opposite direction. Okay, getting it? So the stack will grow downwards. Okay, so always the stack will grow downwards. Okay, and the heap will grow upwards. Okay, so this is the process memory. Okay, so now next we'll see the process state. Okay, the state of a process, that is process state. Okay, so before going into the process state, we'll draw one small diagram that denotes all the process state. Okay, this diagram is compulsory. So the first one is new state. Okay, so whenever we create a process, okay, ready for execution. So that comes into the new process. Whenever we create a new process, it will be here. Okay, so then comes ready. When the process created, it will be a new state, then it will be ready for execution, then it comes ready state. Okay, from the new state we'll have whenever it is admitted. Okay, whenever it comes a condition called as admitted, means ready for execution, it will come into the ready state, then it comes into the running state. Okay, so running means it started executed. Okay, means from the ready state, whenever the scheduler, okay, scheduler going to dispatch it. So whenever it is dispatched, the scheduler means the scheduler is dispatched from the ready queue and pushed into the running state. Okay, from the running state, whenever it is done, whenever a program is done and it comes under execute and state, then it goes to the new state, that is terminated. Okay, that means it's finished, we have terminated our process. Okay, while running, if there is some interruption, some disturbance in the middle, then it want to pause. Or it will pause from the running state, it will again go back to the ready state. So that is when it going to happen, whenever we have a interrupt. Okay, whenever we have a interrupt, so from the running state it will go back to ready state. Okay, in the meanwhile, while running, if suddenly he want to do something, wait for some input output or something like that, so then it goes into a waiting state. So when it goes into waiting state, whenever we are running and we want some input output, okay, or we want to wait for some event, okay, whenever we want to wait for it, then our process goes from running state to waiting state. Okay, once the input or output is done or event is done, so it directly does not go to running state. Again it want to go back to ready state, because some other process will be running in the running state. So what happened when it goes to ready state, when this input output or any event whatever we were waiting for is completed. Okay, so whenever it is completion, it'll go back to ready state. So this is called as diagram of the process state. Okay. Again, you should explain all the 5 process one by one. Okay. Let we see how to explain that. Okay. This diagram is very important. Okay. Once again, I'll quickly tell it. From the new state, whenever it's admitted, it'll go into a ready state. From the ready state, it'll go into a running state. So from the running state, if some interruption happen, it can again come back and wait in ready state. Or if it wants some input, output or any event, it'll again go into waiting state. Otherwise, third option is if it is done, if it is executed completely, it'll go into a terminated state. Okay. So these are the 5 states of the process. Okay. First we'll see the new. Okay. So new state means the stage where the process is created. Okay, this is new state means whenever the process is created, we call it as a new state. Then ready state. Okay, when it goes to ready state means all the resources got allocated. Okay, all the resources it needs to run got allocated. Okay, we want some resources is ready. Okay, it has all the resources. Okay, whenever it has all the resources need to run, okay, then it goes to ready state. Then third one is running state. Okay, so running state means already the instruction started execution, our process is running. Okay, instructions are being executed means our process is already started executing. Okay, then we say it as a running state. Then comes waiting state. The fourth state is waiting state. Okay, waiting state means, okay, so the process needs to wait. Okay, the process is waiting for some event or input output. It can be for event, or it can be like input output, like a keyboard event or mouse event or any input output event. The last one is terminated. Okay, terminated means the process is, the process has completed. Okay, the process has completed its execution, so then it goes to terminated state. So these are the 5 process states. Okay, getting it? So thank you for watching. Please do subscription, like, share for more such videos.